Good morning. Here is another lesson on probability. This one is about probability that each outcome is not equally likely. And our first example is a free throw. We can see that making a free throw is not necessarily easy. And even though there's only two outcomes, each outcome is not necessarily equally likely. Oh, there you go. He made one there. Okay. So we're going to look at that guy. His name is Andre Drummond, plays in the NBA. He is not great at free throws. So his probability of making is less likely than the probability of missing. So let's see what would happen. What is the chance he makes two in a row? Well, first we had to figure out that he has a 40% or 0.4 chance of making it, and that would mean a 60% chance or 0.6 chance of missing it. So to calculate this, first I want to find the sample space, right? What are the possible options? Well, I'm going to do that by making a tree diagram. I'm going to abbreviate, say he can make or he can miss, so MA for make, and he can do the same thing again. Make or miss, make or miss. So there are four different options. I'm going to write them out. Make, he can make it, then miss it. He could miss it, then make it. And he could miss it, and then miss it. So now what I'm going to do is use those probabilities that were above right here, 0.4 and 0.6. I'm going to write them in so that we can now multiply to find the probability of each possible outcome. So making, that is 0.4, this is 0.6, 0.4, 0.6, 0.4, and 0.6. So what I'm going to do to find the probability of each one of those is multiply each probability to figure out what the outcome is going to be. All right, so make is 0.4 times 0.4. That is 0.16 or 16%. Okay, make then miss is 0.4 times 0.6 or 0.24, 24%. 0.6 times 0.4 is miss then make. That is the same as above. And 0.6 times 0.6, the chance will miss both is approximately 36%. Okay, so the question asks, what is the probability he'll make two in a row? Not very good, only 16%. You can see that if we take those two in the middle, 24% and 24%, those two are the chance he's going to make one out of two. So about half the time he makes one out of two, and then 36% of the time he's probably going to miss both of them. Well, number one is with the board games. We're going to play two nights of board games. We're going to roll a die that only has 4 sides and determine which one we're going to play. First, again, I'm going to start out by doing the sample space. So we have a board game or a card game. Those are options: board or card, board or card. So I can write out my outcomes: board game, then a board game, then a card game, then a board game, or both card games. All right. Second thing I'm going to do is I'm going to look and say, all right, if it lands on a 1, that means they're going to play a card game. They'll play a board game that lands on 2, 3, or 4. So that gives me different probabilities. Right. What I have is the board game is a 3 out of 4 because 3 of the numbers will give me a board game. The card game is 1 out of 4. So I'm going to insert my probabilities next to each possible outcome here. All right, 3 out of 4. Now I can multiply. So 3/4 times 3/4. There's a 9 out of 16 chance we'll play board game and card game. 3/4 times 1/4 is 3 out of 16. 1/4 times 3/4 is 3 out of 16, and 1/4 times 1/4 is 1 out of 16. Now, if you look at those 4 probabilities, 9 plus 3 plus 3 plus 1 is equal to 16. So that means I did it right, because if you add up all the probabilities, it will be 16 out of 16. The problem asks, what is the probability there will be exactly one night of board games over the 2 nights? Well, exactly one. This is 1. That's 3/16. This is 1. The board game is 0, and card game is 2. So I'm taking those two probabilities. 3/16 plus 3/16 is 6/16, or there's a 3 out of 8 chance that we will go with exactly one night of board games over the 2 nights. This is one that is really I'm going to enjoy here. The Pittsburgh Pirates and New York Yankees. Pirates are my favorite team. Based on the pitching matchup, that who's pitching, the chance of winning the games changes. So the Yankees have a 60% chance of winning game 1 and an 80% chance of winning game 2. What is the probability they will win both games? Well, we're going to look at it as from the Yankees' perspective. So game 1, they could win or they could lose. Game 2, they could win or lose. Win or lose. So again, I'm always starting with that tree diagram. I like it because it's a visual way I can see what's going to happen. So they could win, then win. They could win, then lose. Lose, then win, or lose, then lose. Again, now I'm going to go with our probabilities. Now I'm going to be careful on this one because the probabilities changes from event to event. So on the first game, they have a 60% chance of winning and a 40% chance of losing. The next one it changes, so 80 and 20, and you'll notice I put them right into decimals, excuse me, because that is the easiest way for me to calculate. Now I'm going to multiply W times W, 0.6 times 0.8 there's a 48% chance. 0.6 times 0.2 is a 12% chance. 0.4 times 0.8 is a 32% chance. And 0.4 times 0.2 is an 8% chance. So, whoa, what did I do there? Sorry. So what we can see again, did I do it correctly? Well, if I look at my numbers here, 48 plus 12 is 60, plus 32 is 92, plus 8 is 100%. So those are all my different percentages. We can see that they only have a 48% chance of winning both games, but they have only an 8% chance of losing both games. So chances are the highest percent they're going to win both. You'll see that there is a 44% chance that they win one and lose one. Okay, so again, what we're doing is making a tree diagram and listing the outcomes, then using those probabilities with the different outcomes to find the probability overall. Now I want you to try this one and hit pause here in a couple seconds, and then I will show you the answers. In 3, 2, 1, hit pause. Okay, that was a bit of a long problem. First thing we had to do was draw the tree diagram to see all our possible outcomes. There are 8 possible outcomes of going left or right. Now, then I put in the probability of turning left or right, and all the lefts were 0.7, all the rights were 0.3. Finally, to find the probability of each one, and multiplied each of those probabilities. So the left was 0.7 times 0.7 times 0.7. Left right was 0.7 times 0.7 times 0.3, and so on and so forth. The question asks, what is the probability that only one of the 3 mice will turn left? So there was only one L in the outcome. So that was left, right, left, right, and right, left, all at 0.063, and so I added those together to get a 0.189. Okay, so what I think you guys should try to do is look over these notes. These ones are a little bit challenging. Email me with questions, and we will talk soon.